How is it, everyone? And welcome to your first class maths tutorials. And in this tutorial, we're going to have a look at joint variation. So if we look at the statement that we've got here, the mass m of a coin of a radius r and thickness h depends on the volume v of a metal in the coin. So this is basically a statement which present what is called joint variation. So if we look at these coins that we've got here, we've got a 5 rand coin, a 2 rand coin, and a 1 rand coin. So it simply means the mass of each and every coin is going to depend on the thickness and the radius of each coin. That is what is explained by this statement. So when we are looking at joint variation, we are simply looking at a variation whereby two parameters are joined together to get what we are looking for. So that simply means m, which represent mass, varies with v, which represent volume, of which we are all aware that for you to calculate the volume, the formula to calculate the volume is pi r squared h. So this simply means that m varies jointly with the square of radius and the thickness. So this is the statement which is explaining the concept of volume. So basically when we're looking at joint variation, another way of looking at it is looking at what is called volume. And then we are going to have an example on joint variation so that we can get the read of what is required. And we are also going to upload more tutorials on joint variation so that we can practice more questions and then get the gist of what is called a joint variation. So the question we've got here is saying x varies jointly with y and z. This is what the statement is saying. When y is equals to 2, z is equals to 3, x is equals to 30. Find the relationship between x, y, and z or z. So just like what we've been doing in all other variations, the first thing that we have to do is to find a constant that will be giving us the relationship between the variables we have. So just rewriting this statement, we've got x varies jointly with y and z. And when we introduce the equal sign, when we remove the vary sign, we are going to say x is equal to, and we introduce a constant which is always k, or basically which is k, k, y, z. So after we introduce a constant, then we substitute the values that we've got, the values that we've been given, so that we find the value of k. So here the value of x we are given that is 30, and the value of y is 2, and the value of z is 3. So substituting these values in the formula, we're going to have 30 is equal to k multiplied by 2 multiplied by 3, right? So we are going to have 30 solving for k is equals to 6k. Divide both sides by 6, divide both sides by 6 to find the value of k. So it simply means the value of k that we have is 5. So this is the value of constant, the first step to find the value of a constant. So now we are going to substitute this value of a constant in the formula that we've got, so that we are going to end up having x is equals to 5y z as the formula which represent the relationship between the given parameters, right? So this is the first part of the question, and then answering the B part of the question, which is saying find x when y is equals to 4 and z is equals to 6. So we know that the formula that we've got, the relationship that we've established is x is equals to 5yz. So now we've got the value of y as 4 and the value of z as 6. So we're going to substitute these values in the formula so that we are going to have x is equals to 5 multiplied by what is the value of y? It's 4 multiplied by what is the value of z? 6. So if we multiply these numbers, we are going to have 120 as the value of x. So this is basically how joint variation works. And always remember that practice makes perfect.